Hello, good afternoon everyone. I'm Aditya Sharma. First, I will take up the technical part and the presentation ahead. So as you can see, first we have started with the prototyping of the project. Like to get a visual representation of what was the function, like what are we building, where are we going ahead in the project. It was started in 2016 by me during my engineering last year. So first I started to get a visual representation like what's the project, how would the model look, how would it work, and further it was followed by the designing stage, then the analysis stage, then the production stage, just to get a clear new product development cycle. So that's the designing cycle. So we have done the modeling in the NXCAD Siemens NXCAD 3D modeling, where the stress analysis has been also been considered in NC software to check whether the sustainability of the product under hard conditions. So now I would like to show you a small video of the designing phase. So this shows the 3D modeling. So from here the trash would be inserted through this hole. That's the cross section of the model. That's the drawer where the liquid would be first stored and the compacted trash would be stored in the second stage. That's the pneumatic cylinder through which it would work and the compress the trash. That's the working area, and that's the below it's for the storage drawer. That's the storage one. That's how the model actually looks like, and that's the pneumatic cylinder through it it would work. I'll show in this one itself. Like that's the inlet through which you can dump in the garbage, and the pneumatic cylinder would compress it. Pneumatic cylinder basically operates through compressed air as a source. At the initial level, we have used a foot pedal pump, the similar which we use to inflate our bicycle tires, just to get an idea about the project. That's the making of the model. Like we use the pneumatic cylinder, the MS sheets, the piston to compress the prototype structure. That was the net to segregate the dry and wet garbage. That's the drawer to store the liquid portion. It would come down due to gravity when it's been compressed with the solid and wet mixed due to pressure from the pneumatic cylinder. So that's the proposed design. It shows different views like front view, side view, left and side view, isometric and all that. So it shows the drafting, like what are the dimensions of the product, like what would be the scalability and the feasibility. So as said by Akshaya, like the feasibility and the scalability is like a very big challenge. Like where you would use, it's the major issue. Like for municipal corporations, it would be in large volumes, like such and big rooms is not a big thing for them. But it can be used for residential and commercial applications, like something this kind of model, it's 1000 mm, it's this much, normal dustbin at your home. You can compress and the issue can be solved easily. This shows the working of prototype, so it would be again followed by a video. So that's the insertion of garbage to get a better understanding, ma'am. For demo purpose, we use the newspapers and plastics to just have an experiment kind of thing. So that was the foot pedal I was talking about, like just to give compressed air as a source to the inlet of the pneumatic cylinder. So load is being applied to the pneumatic cylinder through that DCV, direction control valve. So it shows the wet garbage. Just an example. The Fanta bottle of 1 liter is been also inserted similarly. The results would be shown at last. This shows the net, like in the first stage the liquid is being segregated and the solid would be compressed in the next cycle. Now the solid would be compacted in the second stroke. First the liquid would be segregated. So that's how the compacted waste would be removed in a plastic bag fitted inside the drawer for easy disposal. So that's how the 1 liter bottle has been crushed, like to a big extent. So you can see like what's the amount of compaction being achieved. Like before it was like this much. Then it's around like here. It was a 60% kind of reduction in volume. So these are the results, like the inlet volume, the cylindrical formula pi d square h to calculate the volume, like it's been calculated, and the compacted volume, like how it was before and how it was afterwards compaction. In the next slide, you can see the compaction ratio. It's around 58 to 60%. You can compress trash. So now talking about the cost saving in the transportations, like if you could compress 60% of trash in one such kind of machine. So just imagine like how many less trucks you would require to transport the garbage from here to several thousands of kilometers in major dump yards and the other disposal cycles wherever they have been disposed. So just imagine the kind of pollution, the CO2 emissions, the fossil fuels resources, the utilization factor, the efficiency. It would be achieved like a very good level. It shows the engineering economics, like as you all know, like it was just a project, like a prototype base. So the costing would be very much high because you have to go to each and every different stores and get the work done, outsource you have to. So if you consider like to achieve major economies of scale, so you have to do in much greater volumes. We have to produce more such kind of products in the great volumes to get some benefits of economies of scale. So that's the major challenge ahead if we get with this product ahead. Right. So that shows the costing, like it's around 6,000 rupees just to manufacture the small prototype in a single prototype. That was my thinking. So it shows the business model canvas, like who were your key partners, key activities, value proposition, and the major revenue streams are like just through selling the products, reducing the transportation costs, and market value, or the sponsorship, the reducing of storage costs of garbage, like huge tons of garbage you have to, as an inventory guy, operations guy, you would almost be knowing like the storing costs associated with the inventory and holding and carrying costs. So these are the major challenges, and as well as the transportation is the biggest challenge. That shows the scalable model. So basically 3 kinds of proposals I can tell, like for the first would be like electrically driven. So it would just operate through a switch, press of a switch. You would just go and press a switch, and the trash would be compacted to a great extent. And the second could be like it could be using hydraulic, and the third would be like pneumatic, and the fourth might be using a chain drive mechanism like gear drives and all that things. The future scope are like to add the crusher. Like if you insert certain hard substances like glass, certain ceramics, or certain high density material, you have to crush them first, and then after you have to insert in the compressor, because it can break the pneumatic piston as well. And then the heating source, like certain materials have properties to regenerate their original volumes. So you have to heat them to keep at a certain required stage. So, and the digital display and solar operated are the other things like automated process, technological additions like the IoT and all that things, like it shows the key metrics, a real-time data like what's the level of trash being generated at Holiday Inn. So how would the Mumbai Municipal Corporation know? Like you have to show them real-time view to get the fast pickup of the trucks, of the trash. That's the accepted internationally hydraulic compression and etc. These are the references. That's a small channel made to show what are all the videos that have been uploaded there. So thank you. Any questions?
I think that was a wonderful session. Any questions?
Yes, sir. Yes, sir.
Wet waste is not always only liquid. It's a combination of liquids and solids.
Yes.
And some of these solids are basically bigger size. So does your equipment, you said there is a screen which segregates.
Yes, sir. Net.
What happens to the solid part of the wet waste?
As I mentioned, sir, like the scalability of the product, it depends like what kind of scale the model has been done. Like taking your example for your home, like if you put a Fanta bottle or a cold drink bottle or something like that, or the Minute Maid pulp juice, that as you said, like it contains some solid particles like that thing. So it would be segregated through the net, like the liquid would settle down due to gravity and the force pressure being applied through the pneumatic cylinder. The solid would be floated above the net, as the grain size of the net would be like certain small or maybe less than the solid size. So if it would be like the net size would be more, the solid would go down, or if it would be less, then it would stay up.
No, but if the net size is more, it's possible that some dry waste also would go down and mix with the wet waste.
Sorry, yes, sir, I agree. Like, but if we can segregate liquid and wet, liquid and dry garbage. So the liquid waste is you can't treat them. They have to send in to the effluent treatment plants. We can't treat them.
No, that's right.
Huh.
So basically what you're saying is the wet, is the liquid part of
Yes,
the
sir.
wet waste
Hmm.
is definitely segregated.
Segregated.
You can
Hmm.
dispose it off as
Hmm.
wherever you require.
Hmm.
But the solid part of the wet waste
Okay.
could pass as dry waste and go with the dry
So
waste.
consider a case like by chance it passes down.
Yeah.
So again, that has to be thought by like the
See,
design of the.
normally the system demands, BMC has a circular now that all the housing societies mandatory from
Yes,
1st
yes.
December
Mm-hmm.
have to segregate, okay, and otherwise they will be penalized and they won't collect
Yes,
it
yes.
and all. And 50% of the buildings in Bombay fall under that category.
Okay.
Okay. Now we were thinking in our building,
Okay.
which has close to 200 apartments, how to do it, how to educate.
Mm-hmm.
So the idea was, as you said, put two bins. Okay. The problem with two bins is that sometimes five people stay in a house. Okay. So there's not only one set of dustbin in the kitchen. You have dustbins sometimes in the bedroom,
Yes, yes.
bathroom. So sometimes people keep 2-3 sets of dustbins.
Mm-hmm.
So everywhere you need to keep two. You need to educate every member.
Mm-hmm.
So this is a problem. It's not possible to actually segregate in every dustbin.
Hmm.
So let's say
Okay.
okay, and it gets got spoiled after
Okay.
1 day.
Hmm.
Now what you do is, it's a wet waste,
Hmm.
so you will actually throw it in your dustbin as
Yes.
a wet waste.
Hmm.
Okay. Now, if I give that garbage to you,
Okay.
okay, how it will get segregated? If I put it along with the dry waste, and I put it and I give it to you in your machine, please segregate it.
Okay.
So what will come out as a wet waste and what will come out
Sir,
as
as
a
you
dry
said
waste?
about like the food and the eating stuff, like the food has been majorly, it has to be recycled. Like you must be knowing about the chips being made for the animals through the recycling of food. There are plants like where you have to throw your food to them, like they would make the chips and all the animal eating stuff from that. So that's a different aspect. If you are just talking about
No,
eating
it
food.
could be food item, it could be any item which is wet. It could be some residue from some
Hmm.
other chemicals or whatever it is.
Hmm.
You've done so many things right now in your dustbin
Hmm.
and you don't bother where it goes. Okay.
Okay.
But now you have to
Hmm.
segregate. Okay. So one system is we segregate it, okay,
Okay.
in two bins, and
Hmm.
the other is your machine, which
Hmm.
is preferable.
Hmm.
It's a
Hmm.
very good
Hmm.
mechanism.
Hmm. Hmm.
That let not the people bother.
Yes, yes.
They just jump,
Hmm.
and then you have a machine doing.
Sir, as I said, like the scalability of model, it depends. Like the net design and all have to be, like many models have to be made, like different types of net can be made available. Like if you are passing some solid and wet mix, so it could have be a different grain size, like as I said. So it depends on like what's the usage. As I just mentioned in the initial slide, the scalability of the model is a big aspect to be considered.
Being a mechanical engineering student myself, I
Okay.
find the way that you have gone through the whole model very impressive, like the way to make the CAD model and all. But don't you think the major issue is still an issue now? So even if you have 8 million tons or whatever numbers you have put, even after compression, you will still put the same amount in a landfill. There is no method for treatment of the combined waste that you have just compressed. So don't you think methods like vermicomposting or composting for that matter would be a better way to deal with this issue?
So
Considering the waste that you have collected can then be sold in the form of biodegradable
So
manure.
as she said in the initial slide, like you must have seen that the biogas plants and all that, they prefer the compacted trash to be taken as a source. Okay.
So I think
Hmm.
the question is the segregation will be still required in terms of biodegradable and non-biodegradable, because the compactor will not look at that particular aspect, right? It wouldn't know what is biodegradable and what is non-biodegradable, right?
Mhm.
So uh, we still need the segregation, manual segregation part. This is addressing one of the aspect, which is compacting and reducing the volume of the garbage, right?
So I would just like to give an example, like in this event itself, like you must be seeing like tons and tons of bottles being thrown beside. So how would you transport them to the dump yards and all? You would require 10 trucks. Just taking a small example, like there are certain big aspects. So the compaction would surely help to get the
Definitely.
packaging and the plastics and the logistics